been done from scratch. Obviously we're using SDL and GL for some of this, but still there's no library, we have no pipeline, we've got nothing still basically, and so we're doing a lot and we're working it from the ground up. So this is basically a project from scratch, and along the way you'll learn some compiler development things, language design, graphics work, and some simple things about game design. I hope if you have any questions during the show, just feel free to ask. Otherwise, just sit back and enjoy my ramblings. At some point, I was thinking of putting this little worm over here, walking around on the show. We might test it sometime. Today, there's a couple things I want to do today. Number one, you notice when the game's over, I can't restart. There's no option to restart. So we're going to have to introduce the idea of phases. The other one is when the game starts, you really have no indication that the game's waiting and you don't see where this guy is. So we're going to create a starting menu, and that's going to do a little bit of layout first because these technically aren't laid out correctly. We just sort of fudge that, and this should be the top right. And so we're going to work a little bit in that first, put a little bit of layout, and I'll talk about what's missing from a leaf, what makes this hard, and why this is going to be a bit of a challenge. So let me go open up some of the leaf code. Close that one, and if you're looking for the website that's over on Leaflang, it's significantly lacking in documentation right now. I've been focusing on getting things working, but you can definitely click on the features and click on some of the things like tuples and see basic syntax of how this works. It's not a dynamically typed language, it is statically typed, but most of the types are inferred, so you don't have to worry about that too much. Alright, so let's go back to wherever I was, Wormies, leaf algorithms, SDL, Wormies, and I think we're going to look at the game first. So I've got a big font here just so you can see it on the stream. I've been getting so used to programming with this that it's hard to go back to my small fonts outside of the stream. So the first thing I want to look at is the layout, and that's part of the game renderer. I packed the whole game renderer into one file. It's getting kind of big. And again, let's look at the layout, what I actually want to do. I want to put the Wormies in the top right, and again, it looks like it's there now, but we fudged that, and I'll show you in a second. We want to put the 0 in the top right. I swear that was top left. And we're going to have to space this down a little bit based on pixels. And we're going to fudge it a bit, so we have something called a UI renderer. And what we do in the UI renderer is we have a draw text function. You can see for the text title here, we've totally faked this alignment. We put it at minus 0.83, 0.95, and not just kind of eyeballing it to know where it is. What we'd like to do is say, hey, let's align this to the top left. If you are interested in advanced topics on engine design, let me see, writing UI engine. I've written a series of articles and will continue to write this about writing a UI engine. And I threw it over here, and this is going to cover everything. And what we're looking at now is probably... I don't have alignment on there yet. Well, I'm going to have to fix that. I'll make an article about alignment, and today we're going to work on alignment. And we're going to work with a very bare bones type of alignment. Oh man, I forgot what window I'm on. And the bare bone is I'm not going to worry about symbolic things top left and top right. You can always do alignment with very simple sort of rules, saying where's your anchor position in the outer and in the inner component. So it really just requires two relative positions where you want to do it. And these weird positions are based on the fact that our screen is what did I say? Our screen is based in device coordinates, which for layout kind of sucks. So we're going to start moving towards making this based on pixels and see what actually happens there. We have to know what the pixel size is, and nothing here actually knows that pixel size, which is a bit of an issue. And we should probably pass it down somehow to know what the picture size is. But when we pass the render down, we pass the state. We should probably pass a UI state as well to tell it, hey, this is your window size, this is where you are. So let's go fix that up in the main code right now. We're going to create a structure and pass it down. So we have a window size, but the window does resize all the time. There is a resize event somewhere here. GL viewport window size. We could just look at the viewport, but let's check out the actual size. we're going to define a type for this, and I'm going to make it very simple. It's not a class. I'm just going to make a type out of it for now, as opposed to a class, to keep it simple. And I'm tempted to call it Viewport, because this is what I called it in Fuse before. And it does make sense. There's a bit of an issue with it, but I think it should be fine. And the viewport's basically going to be like, what part of the screen are we using? And it's going to map directly to the VL viewport, except this one is going to be viewport in points. Now I'm going to say points. I'm going to completely ignore the fact that we're going to use pixels for now, but these are going to be logical points, and we're not going to deal with them right now, but we'll just do it anyway. So we're going to have integer, top left, var, top right. Yeah, this should really just, let's make it simple. X is an integer, y is an integer, var width is an integer. So the barbershop, let me just quickly read that. Thank you, Barbershopper. I'm very glad you're enjoying the streams. I do continue to do the Rust streams. I did 2 yesterday and the day before, and I'll keep doing them. And I'm going to switch back and forth. Leaf is part of the reason why I'm doing the Rust streams, is because I'm trying to understand various features of Rust that I want to incorporate over in Leaf. And I'm pretty harsh on Rust when you watch my streams. I bitch and complain about it, but don't worry, I'm going to bitch and complain about my language just the same. But my language and my to-dos, and I slowly fix them. But thanks for watching the show, and hopefully you enjoy this one as well. Even if it's not a language you can use right now, hopefully you can find something of value from this one. That's excellent, Barbershop. Then you're at the right place. Everything I do is at the right place. Language theory is wonderful, and we get everything at once here. Language, language, language. We'll just keep incorporating more. All right, so I have a viewport, and what I want to do is I'm going to create a viewport now. In Leaf, you kind of have the issue. It's very tempting to say a viewport is a viewport, but this is something I'm unsure of how to deal with in Leaf. You can't have a variable with the same name as the type, because they actually share the same namespace. Now, you might be thinking, well, that's stupid, but you can actually do stuff like this. Some type equals viewport, and then do viewport some type. So the type objects are actually kind of high level, and that's why they occupy the same namespace. Now, there is a convention where in other languages, where exactly from Rust, where we might want to say, well, maybe the type should be uppercase instead. And I'm strongly considering this. Usually I don't like this pattern, but maybe it makes sense. Maybe it makes sense because when you have something like a viewport, it's very tempting to say a viewport, viewport, but for now we're going to say main viewport is a viewport. And it's going to start with the size 0, 0, 1200, 800. And actually we should put this here first. So we can do main viewport.width, main viewport.height. And this is technically incorrect, but we're going to live with this for now, because the width here is the width from x. So if x is not 0, this sets it up wrong, but we know the x is 0, so we'll deal with that. What we have to do here is now main viewport, when the window changes size, width equals window size.x, main viewport.height equals window size.y. Now I'm very tempted to say that the viewport isn't actually x and y, it should actually be position. And whatever I call that other thing, you can actually do stuff like this. Type infer, and then call it expression. So we can actually do this, but this is a little bit wacky. Windows size, app.doll window or something like this. And you can infer types this way, but we're actually just going to go look up what size that actually has. This is over in lib, and SD will get window size. Window size. And we're returning a Wow, that's not even returning a strict type. That's just returning some random thing. Well, that's weird. Maybe we have a window size, though. Maybe we have a... In the game renderer, do we have something, an I point somewhere? We have an I point, so let's use an I point. I point being an integer point, var size is going to be an I point as well. Size and position. And so now this tuple becomes a tuple of tuples, which is not a problem. You'll notice the type inference here is that on this side it's still it's a literal, so it can convert this no problem to this viewport. But you actually have to give it a viewport here, because if you take this off, then this will just have a generic tuple type, but we actually want to strongly type this to a viewport. You could technically also do that by sticking viewport over here and casting it. Casting is always safe. It'll just complain if you can't do it. And so now main viewport.size.x, main viewport.size.y. And now size.x equals and size.y equals. Could we actually cast directly? We should be able to. These are compatible. These are compatible tuples, so in theory this should work. If it doesn't work, I think this is a to-do for me. Let's just go and compile this. And expecting type separator. Well, I probably put commas there. There was an open question I asked over on Dev2 that should these things require commas? And the majority is leaning towards no, and I kind of agree with no, but for now they're still there. Although, wait. No, I got rid of them in a lot of places, so it's a to-do. To-do, still need commas in types. That's wrong, because in lists we don't. Or maybe it's something else. Oh no, because I have a var here. I'm being an idiot. Duh. Invalid type syntax 16. Alright, I'm doing something wrong. I'm stuck between projects. Invalid type syntax. Maybe I do need the commas here. Yes, I do. So there's still a to-do there. Still something wrong. In lists we don't, but let's keep going with that. Type lacks fields. Alright. To size.x. It's saying it lacks fields, which is really weird. And that's an I point. I point has an X and a Y, which is kind of funny. So it's complaining about that part. This should obviously not make a difference. Again, if this makes a difference, then we're doing something wrong. A rational 2-bit literal. 22, 40. That's really strange. What can I print here? Main viewport.size. Huh. Something's gone wrong. Oh, shit, I know what this is. Size is a reserved field. Refers to the number of elements in the tuple. Now, should we be allowed to override that? That's a good question. And if we don't override that, what is it? Let's just call this point size for clarity. Main viewport dot point size dot x. This is going to come up a lot when we do layout, because size is a very common one, but if size is referring to the actual size, and I might want to call that a different name, because size is not so often referred to in a viewport or in a tuple. The reason you'd use this is if you're writing a for each function, you can iterate over the fields on a tuple in a parametric function and look through those things. And now I'm at, yeah, I'm missing an error value here. Missing a line on error. Let's do that. Alright, this compile time is kind of bugging me too, and I actually did a profile today, and it's not coming from my compiler, it's coming all from LLVM, and that's really disturbing. Like, Valgrind is showing 88% of all time until the execution starts is coming from LLVM. And Leaf right now is a really, I wouldn't say poor, but it's like absolutely unoptimized. I'm even compiling in debug mode, and it does really horrible things, and yet it's just a tiny fraction of the time, and this is why I'm absolutely shocked that LLVM is taking so long to start up the program. And I have to find a way to do that, because it really hurts the turnaround cycle when I'm waiting for stuff, and I don't think it should be. And it looks like it's all in some pass manager, like it's making some optimization attempt. And what I'm going to have to do is maybe there's a way to turn off the optimizations when we're running inline like this. And I know you might be thinking, hey, that didn't take that long to run, but for me this is annoying, right? It's like 1, 2, 3 seconds. In my world, this is actually too long. This should actually take under a second all the time. And I mean, under a second means you can very rapidly make change, and it's very super to make changes that quickly. Having to wait 3 seconds, this is growing very fast. As our source code grows, this time is growing very fast. And obviously I can split off libraries, but it's also not like we have 10, 20,000 lines of code. We've got like 1 to 2,000 lines of code, which isn't that much yet. So I'm going to have to look into that more. I did double check that LLVM is compiled in release mode, so it's not like a debug thing on there. And I'll probably have to check with the mailing list if there's some way I can get this going faster. And because I think the same thing happens if you write an exe such Wormies. Oh, you can't see that part, silly thing. Whoops. So it takes even longer to write an executable. But that one's okay, because there might actually be optimization passes. I'm not sure. But again, this you know, you're probably not worried about the time too much. But for me, this bothers me because it shouldn't be taking that long. 2.4 seconds given the code size is too long. And so we now have a game called Temp Wormies. Obviously, the startup's pretty immediate. But I'm going to go back to running in this mode where we have it not compiled, because that just makes it easier to deal with. So we don't have to compile and run, we just run it. And I really like this mode in Leaf, that you can do it. So it's kind of like working with like an interpreted language, where interpret I use loosely because they're probably interpreted in the same way I am. They're just going through some JIT. We also have another problem to fix, which I'm going to have to talk to the SDL people about, is we have a lot of frame dropping here. Our animation is not smooth, and that's because we're only getting about 30 frames per second, and it's really uncertain why. And it has absolutely nothing to do with our drawing, because if we remove it, it still get the same crappy performance. Well, let's just move on for now. So we set the window size, and now we're going to pass this down to the window function. We're going to pass the viewport, and this is a fixed size. This is a small structure, so I can still just pass this down. Things are passed by value. Main viewport. We could take a reference to this in the calling function, or we can just pass it down by value for now. State is a service type, which means it's a shared object. We could also explicitly make it like this and say this is a shared viewport, and then we could pass it around as a shared object instead. But since it's so small now, I'm wondering whether it's actually valid or not. Shared things obviously have a lot of overhead. I mean, we wouldn't notice it at this point, but let's just not do shared for now. Let's have an example of passing structures. It took me a lot of effort to get the ABI implemented correctly for shared structures, so we're going to go with it now. So render, start at the top here. Where's the first render function? Now this just takes a main viewport. Oh, I'm going to say, I just say a window here and call it a viewport. Or call it a region. Region makes sense here. And the field renderer, we're just going to ignore that. I won't pass it to both of them. We'll let them deal with it. And where's the render function? This takes a region, and this takes a viewport. And this takes a viewport. Now this is in points, which is really kind of weird how we want to do that. So what we'd ideally here is this viewport here, we're going to split it up and make the renderer, the field renderer, or the field renderer be in a different part, as you saw the game split into sections, and put the UI renderer in the top part. So what we actually want to do is we actually want to do this. We want to say UI region equals region. We're going to copy it, and UI region dot height equals, I don't know, let's just say it's 40 pixels high, 40 points high. So it doesn't matter what the screen is, we're going to make it 40 points high. And then go UI region, and we'll fix this part first. And so UI region here, game renderer, but, oh no, this is really, The region actually has to keep the original size in order for the calculations to work. So we have to keep the full window size and the local region size. So why don't we just add that to it? Why don't we add here the viewport? We're going to put the window size as an eye point as well. And the reason we're doing this is because, and the region is a position and a size, and this is for the region. And this is for GL, because we have to do the mapping on our side. We have to do the mapping for our size, and this is technically here, window size. And maybe this gives a better name here. We have a region position and a region size then. Region position, region size, and we're going to do it region size equals this, and we'll leave the same point size. Now what we really want to do is we want to make the top left, because that's typical in UI, and we're going to have to deal with the inversion, and we'll get to those calculations right away then. So we have a viewport, and we have a region. Now we just have to figure out, what do we want to draw here? We want to draw text. And the draw text, alright, we're just going to do it all inline for now. It takes a position, and it takes a height, which is really weird. No, we're just going to use the height of the text itself. And the position is actually saying the anchor and the parent. And then we need the anchor and the child. And we're going to do an anchor GL float 2, and that's where in the child we're positioning it. And for this to work, we actually have to have the region in which we're drawing. And this is a viewport again. And here we should probably start passing by reference, but it's still small enough that I don't think I'm going to have to worry about it. Alright, so we're going to have to do a few calculations here. What is the width? So where are we getting the width from? What is source size? Where is that coming from? Text.size. So this is in pixels, and we're just going to pretend that this is in points. And what we need is a function now that converts a point into an NDC coordinate. So let's create a function up here. Define point to NDC. And this is going to take some sort of point structure, a GL float 2, I imagine. So we're going to take a point, which is a GL float 2. We're using GL floats here just so we map correctly into the into the GL coordinate system, and we're also going to take a viewport, or a region. This is going to be a viewport. And here I'm going to take it by reference, value ref. This part of leaf is kind of undefined now. I needed this absolutely, but I don't like the name, and I don't like that this implies sharing of a value. It's meant to serve a different purpose, but it actually ends up doing the same thing. Return values are implied if you return something. And alright, so we have a point, and this is in the screen space. This is in the screen space in the region, and this is relative to the region. So the first thing we have to do is we have to convert the point to, so this is actually a region point. Be very clear about this. The first thing we need is a world point. A world point is going to be a GL float 2 as well. Don't technically need this, but let's do it this way. And right here I don't need commas, and this is going to be a GL float 2 of region point.x minus region dot, what do they call it again? Region position. Oh yeah, this is just wonderful. Wonderful naming. And this is an integer, and this is a float. Now integers cannot be stored in floats without a bit of loss, so we're just going to do this. We're going to convert it this way. That's lossy. And region point.y minus lossy region.region position.y. And this is why I can't use a minus operator here, because I got a lossy, and I have to think about lossy compound conversions to make this easier. So now we have a world point, and this is without the, but we have to convert that into an NDC coordinate. And so the NDC coordinate here now becomes, and I'm actually going to imply the return value, because then I can actually directly convert to it, GL float 2, because I don't want to write it here, I just want to directly return something and let it imply the type of it. So one of the things, either I have to fix the type here, or I have to specify the type in the return. You'll notice I always specify return values in a value list with brackets, and that's because all leaf functions support multiple return values. 0, 1, 2, 3, whatever you want. Alright, so now what we have is world point.x divided by, I'm going to do lossy again, region.windowsize.x. I think it was window size. So we're dividing it by the window size, and this does a value of 0 to 1, and what we have to do is do times 2 minus 1. If you've ever done work with GL before, you'll understand this times 2 minus 1 very much. The NDC goes from minus 1 to 1, so to map from 0 to 1 to that range, you times by 2 and subtract 1. And we're going to do the same thing for the y coordinates. And so now we have a point to NDC function. I'm going to start documenting this stuff, because why not? Convert a position in region coordinates into GL NDC coordinates. Now I think this is actually wrong, because our NDC, the 0, 0 is in the middle and the minus 1 is in the bottom left. So I think we're going to have to actually invert this, but let's take a look first. So what we actually want here now is a var of NDC position. NDC position equals, and oh, I keep forgetting names. When I talk, I forget the names. I'm really sorry about that. Point to NDC, very logical names. Point to NDC. And which point do we actually want here? We want the position, and we want to give it the region. So now we have the position, but now we actually have to have the size as well. Or, whoa, what's actually setting the size here? We're going to have to change the fragment shader as well. I don't think anything actually sets the size. Placement position. Oh, because uniform placement is the size and height. Okay, good. And now we also need the NDC size. And now I'm going to do size to NDC. And the reason I do size is because the size doesn't have that adjustment for the position. It's always considered relative. And so now what we're going to do is we're going to take the source size. And here I have to do the conversion again. And I'm really wondering how to do this in a language, because source size is a tuple of integers, and we need a tuple of floats. And logically, if you're a programmer, what you'd really want to do, because I'm going to have to make this lossy in both counts, is you'd really just like to say lossy on the whole thing. So what I really want to do here is just say lossy source size, but this is fairly complex from the language viewport of how I do this. And I'm going to put it here anyways because it's one of those interesting problems. How do we actually do this from the language? When I put lossy on a tuple, does it actually imply the bits are all lossy? It probably does, and if that's the case, that's actually reasonable to do. But if it implies something else, then I don't know. Does it imply the names get erased as well? I don't know. Because when you do it this way, it's erasing names as well. If you do it this way, there could actually be names, and name compatibility is an issue. So size density of region. So let's do NDC size, 0.2. Now it's going to look very similar, so I'm just going to start from copying it. Convert a size and region into GLNDC size coordinates. Size to NDC, region size. And the important thing here is we don't need this world point anymore. We're going to say world size, but the world size here is very simple. World size is just equal to region size. So there's not really a conversion, but we have to... I like to do it this way just because it's consistent with here. It's a world size. And as we start going through layout and doing the actual full engine, these will not actually be the same. There will actually be a conversion here as well, because the world size is, we may have scaling, but let's just ignore it for now. And so now the second part is exactly the same. You have the world size divided by the window size, and that's okay. So we have size to NDC. And so now we're going to set the position, what we haven't done yet is we haven't adjusted for the anchor. So we've just taken a position and we're going to position here. So this one we want to say 0, 0. And I get rid of the anchor, and I want its anchor to be 0, 0 as well. This is going to work wonderfully for this one. And the draw text one, though, for the score, I actually want 1, 0. So this is the top right. Sorry, no, this has to be in... these are now in point coordinates. So this has to be region.regionsize.x. Maybe we should accept relative here. When you do layout, as I get on, layout's a very difficult thing to get right, and I've done it right in a project, and it's going to take a long time for me to recreate it. And the anchor, however, anchor is almost always a relative size. And this is 1, 0. So we have a relative anchor here instead. And I'm going to ignore that for now. I'm going to see what happens when I just draw it this way. Uniform is NDC position.x. NDC position.y. I see that I spelled it wrong. Just a second. NDC size.x. NDC size.y. And this is a GL function to set the uniform. This is a 4-point of ECK4, a uniform that specifies the position and size of that text rendering. And unexpected node type on 122. That's sort of my generic parser fallback when it says it doesn't know what's going on. And I may have screwed it up with the comma still. I really thought I fixed that. And that might not actually be it. Oh no, I actually didn't. I fixed it with commas, so never mind. I know what I fixed. We still need commas here. I fixed something else. I fixed it so that binary operators can span multiple lines. And the binary operators we're not using here, but now I have to understand, what have I done wrong here? 139. Okay, so that was the same thing. I forgot the commas. And sorry about that, I haven't done the feature yet. What I've done is I fixed this so that the division goes on to the next line. That didn't work before and we were forced to stick stuff on one line. But now binary operators are allowed to go on to the next line because we don't usually use semicolons to end. Tuple does not contain the symbol height. That's totally correct. Region, and this is now region size.y. Make it 40. Alright, all sorts of... Okay, now this is the worst possible situation we can have right now, and I've hit this error a lot. When you use some inferred typing, occasionally it can't figure out what type it is. And this particular game, this code, has the weird situation that it gets stuck. And it doesn't really know where that unknown type is. And so we can help it along by saying this doesn't return anything. That might help a bit. And then we get better errors here. And we have that 222 now. Alright, and this also has to pass a region down. Now I'm unclear as to why this didn't type it, because there's only one match. To do, missing region gave incomplete typing. And this may have to do with the overloading engine, how it's mapping that incorrectly. And it still has the exact same error, 223. And that's probably because 233 has an error. Position and region is a viewport. Point to NDC. What does point to NDC again do? Takes a GL float to value ref to the viewport. This is a GL float too, and that's a region, so it should be, that's a viewport, so it should be able to take the reference to it. Now I have to figure out why. Why does it not take the reference to it? And this is on type 223 here. And again, these implied return values, they can sometimes confuse it because it can't figure out the type now, because it's failing the type inside here. It means this type it doesn't actually know, which means it doesn't know what type it is here. And because you can't ignore return values. So you're always allowed to stick these in, but generally I'm trying to avoid that. And these are just compiler errors. And so now it very clearly points out just the one, just 233 is the issue. And we already had that, so we can do that anyways. But why is 233 causing me grief? If I take that out, it just goes to 235. So I have some weird conversion issue. Position is GL float 2. Region is a viewport. Oh, I know what it is. And it's exactly what I said about abusing value ref. Parameters are not, they're immutable. You can't change them. But if you try to take a value reference to a parameter, it gets mad. And that's what it's complaining about in its horrible, absolute horrible way. And I'll put to-dos in those to fix it. So many to-dos. You can see how this, we're just going through this. To-do add a kind of read-only value ref. And this is what I mean about this part's not working. Also part of the to-do, also to-do, adding value ref, cause typing error instead of clean error message. Again, we're not worried about efficiency right here, so we're going to pass the whole viewport again. These are more than likely just going to be packed into a couple registers anyways, so we should be fine. Index size, okay, I forgot to change that to 238. I said I pointed it out, and NDC size, where did I put that? Now let's see where they go. So they're not going anywhere. We've totally screwed something up, and that's totally fine. So we're going to do a bit of debugging on that first. We don't have a testing library or anything, so I'm just going to do some printing out here. Crazy as that may sound. Now, I don't actually remember if I print tuples. This might actually print garbage, because I'm going to pack them all together. Yeah, it packs them all together. But it looks like it's right. So -1, -1, and, well, those second values should not be negative, of course. Oh, that's corrected. I screwed up the size again. NDC, whoops, size to NDC. We don't do the -1, we just do the minus here, and that creates a better size for it. And you notice this way at the bottom now. And that makes sense because we didn't invert the world coordinates. So, how do we do this now? We have to invert them. And the way we can do that is we can say, well, this is actually 1 minus this, and this is 1 minus this. And you notice the size, though. I'm inverting the size, and that actually makes sense because we have to invert that too. And it's probably going to be flipped upside down now, though. Well, now it's just really big. Actually, this should be 2 minus. Alright, so I got something wrong there. And this is actually 1 minus this. And what if I just don't invert the size? That should make it actually upside down. Now it's just going in a random place. It's actually just minus. I shouldn't do the subtraction. It should just be minus, sorry. And where is my rectangle? We have a missing rectangle. Alright, this is fun. So now we're actually debugging. I like debugging in my language because, you know, it means I'm doing something wrong at the high level. It's not my debugger probably screwing up. So let's print these all out again. Let's print out size.x, comma, NDC position.y, comma, that's just more of a space, ND size.x, comma, and now this print line is actually a printing facility. That's why it doesn't join anything together. It doesn't space out the tuples because it just says it prints all the things it gives it, and if they're tuples, it just iterates through them and prints them. And that's pretty much what you'd expect from a printing function because it's not a debugging function. And I'm going to get rid of the second text here. I'm just going to draw the title for now. Let's see where that title is. And this is where I mean the turnaround time would be super if it was faster. Alright, so -1, comma 2. Well, 2 is obviously wrong. 2 cannot possibly be the position because 2 is stupid. 2 puts it off the screen. It has to be between the range of 0 and 1. So I did the subtraction wrong. How do I convert this? I want to invert this again. We have a number between -1 and 1, and I have to flip it over. Maybe I should just flip this one first. 1 minus world point.y. Yeah, divided by, not by that, but divided by that. Alright. There you go. So now it's upside down, and that was, you know, kind of expected. Not really expected here. Right, it is kind of expected. And so we're actually getting the correct coordinates up there. Well, I'm in the wrong folder now. Alright, this is the correct size, I think, except for the fact it's too big, because this is actually sized differently. The upside down, we have to deal with this. Why is it upside down? And that has to do with the texture coordinates. And texture coordinates are a pain in the ass to deal with in this sense. We can simply invert the texture coordinates again and start with 0, 0 and go to 1, 1, and that'll invert it. Oh man. View spaces are a pain. So we have the correct space right now. And we're not stretching it anymore. That's the key thing. It has a much clearer appearance because we're not stretching it, but actually we are. Yeah, we're not stretching it. Maybe we should stretch. Alright, it's fine. Where was I? Do that. Let's put the other one back in place now. This one's not going to show up because we don't position it correctly. Right, so it's positioned up here, and then it's off the screen. So this is where the anchoring comes in. Let's get rid of the print line. And the anchoring then says, oh, what part of the thing do we want to position up there? And this really becomes down to, the size is always the same, but the position ends up being minus relative anchor times ndc size.x and minus relative anchor times ndc size.y, or maybe whoopala, no matching symbol. Oh yeah, because this is a float too. .y, .x. Yeah. All right. So it's now aligned to the top right, and these sizes are fixed for those texts. Now that's what we wanted, or we thought it was. We screwed something up. My guess is that somehow the window thing is not updating its size. Yeah, that's correct. In the main leaf here, we're not updating the sizes correctly. Main viewport window size equals window size. So now this is what we wanted. The text doesn't change size. And you know something weird about SDL? It moves it to a different spot first, and I'm not sure if this is SDL or my compositor doing it, but it really looks like, I think it might be the compositor inferring what the frame is. So now our text thing here is too big. We don't really want that. We want the text to be a bit smaller. So we're going to ask the one thing for what size it has. And we probably also want some padding here now. We want some padding with the margin there. But let's go and change the renderer. I know this seems like a lot of effort to lay this out, but again, we don't have a layout library, so everything we have to do on our own. Typical when you're doing stuff like this. And we're not stretching the text now. That's important. We're not stretching the text anymore. We're actually just saying, look, just draw the text for its actual size. And our size should probably be a bit smaller. We're going to make the size more like 40 in size. To match the point size we set up here, we said 40, and that should actually fill it up. Or I'm going to ignore the dynamic sizing, let's just say 40. And so now it fits in there perfectly, top right, top left, and is properly aligned, regardless of the size. And it's always the same fixed size, except the screen itself, you notice, doesn't come down, and this is because we have to adjust the wow, that did something weird. There's some weird SDL thing, and I'm thinking that's what's also causing my slowdown. We have to position the character correctly. That little cat should... Yeah, there's a reason why he's appearing at the top there, and that's kind of a problem. He doesn't partially appear in the bottom. You notice he just suddenly appears. It's because his partial render's on the top, but I'm just going to ignore that for now as well. We need to dynamically size the top thing here. And so we're going to do the same thing. Var field region equals region. Field region dot region position dot y equals 40. We're going to shift this down, and we're going to subtract from region size dot y minus equals 40. Now the renderer doesn't use this yet, so we're going to have to go over to the field renderer and figure out where that is. And where's our render function down here? We create this transform matrix. This can do a lot more than just shift it, but we're just going to shift it for now. We're going to scale and shift it, but we have to actually figure out what the size is. We could use the NDC thing, or we could just assume the size here. Region.region size.y divided region.window size.y. But these have to be cast to a float, otherwise we're going to get integer division, which is not what we want. And we're going to cast them directly to a GL float, because that's what we have. And by cast here, I actually mean doing a lossy conversion, because these could have values that technically can't be represented as a float. So we're technically losing precision here, but we know what we're doing, and we'll be okay. Lossy GL float should fort. And now we have to say, we want to offset this a little bit, and the screen's inverted. And we're just going to pack this down here, region position.y, and hope that does it correctly. Oh, I did something wrong. Not possible. This converts, and this has to be... That's a bit weird. We did a... I think I may have wanted to do minus. I don't remember anymore. I've done something wrong, that's for sure. Well, what we had before, let's just look what we had before. Minus 0.5 and 0.95. Let's copy this. And figure out what we had. What are these values coming out to? Again, let's just debug this way, standard print line. Putting all this stuff into a library and testing it would be the ideal approach, but I'm just trying to show progress in the language before we build up everything. I don't want to go right into testing until we have a functioning language, because the test library would then not look correct. Transform to M22, comma, 42. And what's coming out there? 1 and minus 0. Yeah, and that's because I forgot to pass the region here, so it was probably doing the right thing. There we go. That's working correctly. So now we have rudimentary layout. It keeps the size of the top. So the size part is fixed. It's 40 points. And the game adapts accordingly. And so that's very rudimentary layout, but that's exactly what we want. We're going to do more of this layout. And if you didn't know, the bushes kill you as well, so if you run into a bush, you die. And you notice it does a sudden spring at the end. We have some graphic things to clean up. But the points here are enough too. Oh yeah, that was the reason why we wanted to do a right alignment of points. The reason it wasn't the pointer in the middle before is because when you got to 10, it had to change the alignment. We couldn't do that. But now when we get to 10, the points are actually going to change their position. And I just got to get to 10 first. Oh, you stupid cat. Or, that's not a cat, that's supposed to be a bear. We just picked it up and fixed it. So now you have 10, so now you can see the top right alignment based on the text size. And that's what we want. We want to get that. And so that can now be done. We have the alignment, and we don't have to hard code the position for these things. We just say relative to where we want them with an alignment, and we position them. So Reknakas is asking, I've heard you're going to write a bot for this game. It's going to be 2 players, AI or versus human, or just AI. Are you talking about another game? No, I do want to write a bot for this game. I want it to be... Well, we can go in that direction. I want to have basically 2 players where 1 player could be a bot. Or, 3 or 4 players where multiple players can be a bot. And I think that's the approach. Why I'm doing this alignment now, because to set that up, we're going to have a title screen. And for the title screen, I have to be able to align text at various positions. And that's why I'm doing the alignment now, so I can actually start setting that up. But then we had a Tron bot from over on Coding Game, and that's Tron. This is basically the same game, and we'll do the algorithm on this to show how you write a bot for this. And I have a feeling that even our basic bot from over at Coding Game is going to be really hard to play against. He's going to be superior to the human player by quite a bit, but we're going to have to adjust the bot a bit anyways, because the game's slightly different. Your tail disappears. But the other bot, the Tron bot, wouldn't have to anyways. Yes, it's going to be a release mode, and I'd love to think that speed won't be a problem, but again, my language is in its infancy, and it does some rather really silly things. But so far, it seems that my language isn't the speed problem here, and based on this type of game, it's not going to be a big deal, I think. But we'll find out. We do have a fairly small one, but I think we'll be okay on that. And we can actually compile in release mode as well. Leaf is really not very efficient right now, but it should be enough for simple bots, because we will compile in debug mode, not release mode. Alright, so where's our standard print line? Not here. That's fine, that's fine. We don't really even need these anymore, do we? Get rid of this debugging crud. We don't need that. Alright, so now we have basic positioning. Get status. Git commit AM. Adding simple alignment. The next step is a bit tricky. The next step is from game design. We have to create states. And the states are very interesting in game, and it's a matter of, well, where do we keep the state? Is it actually in the game itself, or is it somewhere else? And by states, I mean, are we in the title screen, or are we in the game, or has the player died or something like that? What state do we find ourselves in? So now let's actually start adding states to this, and this isn't going to talk about the renderer too much. We're going to go back to the game itself. And the game has the actual game field. This is the stuff for the game field. And this is where we may want to break it now, and is that this is no longer part of the game. We're going to have an actual app state. And this keeps it separated. So let's create a new class now, a class app state. Oh, we actually called the game. We didn't create a class out of it. Yeah, we create a shared game here. Okay, that's good enough. So now let's create a class app, for lack of a better term. And this will be an app.leaf. Now the app is going to have a game in it, or shared state, a game state, a game state. This is one of the fields is going to have. It has a game state in it, but it also has phases. And I'm sorry, I'm going to write a to-do first. Leaf lacks enums at the moment. So we're going to use integers for this. Literal stage main. Stage menu will say equals 0. Literal stage play equals 1. Literal stage dead equals 2. So these are the stages of the game. And so now we can have different stages, and we can see what actually we do in these stages. And so we have a bar stage, and we're just going to call this an integer. And the default constructor is just going to do this. It's going to say, we can initialize this to stage menu right here, stage menu. And the shared game state will create it on its own, but the shared game actually needs to have a it constructs a size on its own, so we don't have to do anything there. Okay. So we have this app now, and how we do the screens are going to be a little different. Because Leaf is lacking a bit of object-oriented concepts right now, it's a little tricky to do some of these things. But we have lots of experience with doing non-object-oriented design from like Rust, because Rust also is, but in fairness, Rust actually supports what we need right now in terms of traits and stuff. And this is the next big item I have to add in Leaf, are these traits or interfaces, as you would call them in other languages. And so what we interpret in these phases is going to be really, really weird, because this is really just going to maintain a stage, and it has to go to gameplay and stuff. We're going to have a function like start game. Start game, and this is, I don't know what this does yet. We're going to create probably a new game state. Game state equals type shared game, create one of these. And this resets the game entirely if we start the game. It starts with an initial game as well, but when we start the game, we're going to do a new one, and that's really weird. It should be more like end game, so I don't have a reset. We'll figure it out, because if we're overlaying the start menu on the actual game screen, it'd be really weird to suddenly create a new one, but we can do that. Alright, so let's go over to main, and let's fix this up first. So we want state. We want an app. And again, here's the exact problem. You'd want to call this app, but they share the same namespace. So it's like, well, that's weird. So what do we call it now? And we're just going to call it like, Well, maybe we should start with the convention that types have an uppercase. Or we think of some other convention for this, like this is our app instance, and I don't really like that, to be honest. And this is going to be a shared app. These are automatically initialized by default. You don't have to worry about this not being initialized. And where is state? And we're going to do app instance dot, and what do we call it? Game state? App instance dot game state. App inst dot game state. I always get nervous when I have these multi-level references here, because I mean this is a fairly difficult thing to do in the compiler to get this working correctly with the L values and the references. It should work, but I get nervous doing it. Now we want app instance dot step, because this is actually going to be the state controlling what happens here and passing it off to the game. Now the renderer for right now, we're probably going to pass this through the actual state as well to choose what to render, or we figure it out right here. But this is app instance dot game state. But we need a step function. I think. I really don't know here yet, so let's just put it here. Elapsed is a float. Game state dot step. Elapsed. Now we haven't actually implemented the stages yet, so this is just Construct. Wow, to do. So the duplicate symbol is actually correct, which is correct, but weird. The reason it's correct is because if you don't create a default constructor, it creates one for you, but then creating another thing called default, which is not the constructor, just confuses it. Invalid symbol 28. Shared app. What's complaining about? Oh, yeah. See, these share the same namespace, so this gets confused here again as well. Let's just call this game app then. Naming sucks. Alright, so the game is still going to work because we haven't actually fundamentally changed anything. And I don't know why I'm playing this. I just get addicted every time I play it. I've watched this stupid thing in Tron so often, and every time I see it, it's like, well, I can make the right decision here, even though I'm probably not making the right one. A bot would play the game much better than I would, because it would do weird things when going to things. It would do stuff like this, and a human player just wouldn't do that type of stuff. Oh, wonderful. Alright, so I have that. And now you might want to put the pause as actually part of the game, and so this transition is going to be a bit of an issue. So main leaf here. I'm trying to think. Translating these events is going to be an issue. We want to unpause it. It's not an unpaused game. If the key is down and we're in paused, I'm going to take like a 2-minute break. I'll be right back, and don't leave on me, but I'll be right back in about 2 minutes. Alright, and I'm back. I opened the window, hope it's not too noisy, just let me know, but it's getting kind of warm in here as well. So, this is the really hard part about architecting any type of interactive program, is how you do these stages. And because I don't have some of the object-oriented stuff available to me yet, it gets even more challenging, and migrating stuff gets hard. And of course I have some guy yelling out of the window right now. It's always typical. So like what happens with a key event, it really depends on what are we doing, like what phase are we in, what stage are we in. Do these motions, this should actually control a menu in the one stage and not in the other stage. And pause only works in one stage. So how do we actually do this? Quit and window events, they happen anywhere. And now we have to have these stages, and I'm going to have to split this function off a little bit to give it a state. So let's create a function called, and I think this is key. Key is fine. Key stage menu. And this is going to have to take the app, whatever we called it, app inst, which is just shared app, shared game app. And it should also take the key events. Now the fact I can't see the symbol there is just kind of a weird Kate rendering bug. And it's going to take one of these things. Let's just give it a value pointer so it can deal with it efficiently. Why am I using non-monospaced font? I actually gave up monospaced fonts a long time ago, and there's several reasons for it. One of the big ones is I actually do a lot of other writing in my text editors, and if you're writing like prose, like blog entries, any type of story or something like that, monospace just really sucks because it's hard to read. It's really hard to read monospace. And switching back and forth with coding isn't so good because I use the same editor. But then I started realizing, actually my code looks better too with a non-monospace font. With a proper font, I mean, you have much nicer fonts available to you, because the monospace ones are always like an aftersight. You don't have the same level of investment. And then I actually got to web programming, where there's lots of stuff like Unicode stuff and Unicode characters, and those look like utter shit in a monospace font when you have like different symbols, UTF-8 symbols, Unicode, emoji and stuff. And so that starts all falling apart. And so I really think the time of monospace fonts is going behind this, because it just can't adapt to the level of font requirements we have, even for coding now. The world doesn't live in ASCII, and monospace font really doesn't work outside of the ASCII realm very well. And I still put up with it in a terminal, because the terminal, I don't have a clear answer on how they're supposed to do formatting here. But even in the terminal you get weird stuff like this face here. It's a crappy in this monospace fonts. What I'm using here for Kate, it depends whether you like serif or not serif. The reason why I use a serif font is partially because of the stream. It's easier to see the differences, but again, I got used to it again. It's just easier when you have these little serifs on things. It's much easier to recognize things like I's and L's and 1's and stuff. And what I'm using now, I think I'm using Liberation. Oh, I'm using Bitstream Verisaf. I'm using Bitstream. The Bitstream fonts are very nice. The ones I've used in other streams are the Liberation ones. Liberation is also an option. And so Liberation serif is probably going to look about the same. It might be a bit fancier, so either one of those, I think. And they both have a full character set, but Kate also uses a fallback, so I really like it. And I also like things, because like right here, when you see these things here, like brackets and stuff don't take up so much space, and because brackets are such a common thing in programming, you don't want them taking up excess space. You want them to take up a reasonable space, and I think it just looks a lot nicer. It's also the way math tends to be written. When you do math equations, you don't use a monospace font, so I don't know. It's like, I think it's a historical anachronism to use monospaced fonts, and I wish they would just disappear. Alright, so we're going to keep going with this. Key stage, key menu, and this doesn't have a return value. No problem interrupting. That's the whole purpose of this thing. Alright, so we're going to take this down here. We're going to put the key stage menus down here so we have a separate one. You'll notice my use of any. We'll get back to this lambda this closure here. It is a lambda, but everything in every function in Leaf is actually a lambda function because the functions themselves have no names. You'll notice that we assign to the name as opposed to actually giving it a name. So you can assign to the same way to any name a variable as opposed to a definition. But we have an issue with pause here now. That pause is not a variable that it can see right now. So this is going to be part of the app instance. Let's put it here, app instance. This ticks is going to be an issue. How we manage the ticks, where they should actually happen. I'm going to do something simple for now, which nobody's going to like, and everybody's going to say, hey, don't do that, you're being dumb, and you're going to be absolutely correct. I'm going to take pause, and I'm going to stick it out here. Last ticks equals 0, and I'm going to initialize it. So don't get mad at me yet. There's only so much I can refactor at one time. Get elapsed is actually a time in seconds, so let's just call this a float. We don't have to initialize it. It starts initialized and get elapsed. So global variables are okay, and in some cases they're okay because this is really isolated here. Ideally, I wouldn't do this, and I'll eventually refactor it. So just give me some leeway, because again, I'm missing everything in this language. I have nothing. Okay, so we have that key stage menu, and we'll just call it directly now. Key stage menu, and you see this is where we're going to put the split. Depending on the stage, we're going to call a different function. Key stage menu, and this takes the app instance and the key events. And if we did that right, key events, unknown. Oh, that's right, because down here I call it again as well. And for simplicity, I'm just going to call a key event here so I don't have to rename everything. So, this should still do the same thing. Yes, we refactored successfully. And I'm actually recompiling far more than I usually would in another language, just because you saw earlier we have these errors which are like sometimes indecipherable. So if I do too much code at once in Leaf and hit one of those errors, then I have no idea what actually caused the error. And I do go back to the to-dos and I figure out where the errors are coming from and I slowly fix them. But this is going to take a long time. I mean, there's lots of stuff to do in a compiler. If anybody wants to help out with the compiler, please let me know. There's tons of stuff to do. We're still missing essential features though, so at this stage it's like a massive uphill learning curve if you've not done compilers. Once we really get to standard library stuff, it'll be an easier learning curve, and once we get to examples and stuff, it'll be even easier. Alright, so we have this stage thing here. We have key stage menu. So now we can do the simple split select. I don't actually have a switch statement yet. I think I've done before. Lacking switch. Well, I kind of do, but the syntax is weird and it's going to break on me. There's a select statement which can return a function. And, you know, let's actually do that. See if it actually works. So you can actually have a select, and in a series of functions, we're going to say app_inst stage equals, what do we call these things? Stage menu. Well, actually, just forget about it for now. We're going to say, well, this wasn't key stage menu. This was key stage play. Key stage play is what this was. And we're also going to have one called key stage I forgot what it is. Key stage dead. Those are the only states we have in the game. Key state dead. So if we're in key stage menu, we're going to return key stage menu. We don't have a proper casing system. You have to do the comparison each time. I'll get that way. Play. We're going to do key stage play. Otherwise, the default is going to be key stage dead. We shouldn't actually. We should have consistency. So this select actually says choose one of these functions, and then we can call it. Now I've never done this before in the language. In theory, it works. There might be a test case. And these are high-level functions, so this works just fine. High-level functions meaning that, or first-order function. Oh, I forget the thing. You can return functions by value. You could actually stick the functions directly in here. This is what I meant before about them being lambdas. You could take this whole chunk here and stick it in line, but why on earth would you want to do that? It's really good for short functions, but otherwise not. Alright, so that should work. And it didn't complain us, but now the keys won't work, which is what we expected. The reason keys don't work is because we're in a different stage, which is perfect. It's calling key stage menu, which does absolutely nothing. We don't have a key stage for the menu, so let's do something really simple at first. Let's do, well, let's do a hidden menu first. Let's do a function called S to start the game. Key event dot keysim dot sim equals edA-qa space. Now we've been having trouble with space before. There's something in SDL that it doesn't always work, so I'm uncertain about this. Then what are we going to do? We're going to do app-inst start game is what we called it. And I pressed the wrong button. I don't know how that happened. So I exited in the middle of the stream. Mainly. So we have a company called Start Game. Now we changed the game state, and we have to update the stage. Now the stage is stage play. Alright. We don't have an event loop, so this is going to be weird. We do have an event loop, but we have no way of deferring this. So this is suddenly going to switch to the game mode. But let's see what happens. In theory, so nothing's happening now. I mean, the keys go nowhere. But when I press space, the game should start. But nothing happens still. But then when I press a key, but again, this is... We think this is a problem in SDL. See, it does eventually start. SDL is not giving us a space character, and I don't know why. I would like to figure this one out. Right, like let's do a standard.print line here. Key event key sim symbol. What symbol are we getting in these things? We're not getting the ones we expect. Right. So if I press up, you see key up there. Press left, you see all those keys. And when I press space, nothing happens. I don't know what this is doing in SDL, and it's kind of annoying. So if I press like a key like and it's like random text characters work. If I press one text bit at a time, but if I hit a whole bunch of them, and see suddenly it takes it. So I don't know what this is. Let's go figure that one out in SDL, because this one's actually angering me. We have an SDL key down. What other events do we have? Let's check it first. SDL key down, not generated for keystroke. Alright, do we have a basic problem? Well, this is not our problem. We're definitely pulling in a loop, so that's not it. We have SDL pull event here does not equal 0. We keep pulling in a loop, and oh shit! Look at this. Wow. Well, that explains that. We're pulling. How does anything work? Oh, sorry about that. This is surprise. We're double pulling all the events. I'm surprised anything at all works. Alright, now if I type a key, now I get it. That's much better. So now when I press space, it definitely works. You can see the screen switch. Alright, that definitely helps. So, mystery solved. So we didn't have the same problem as the guy in Stack Overflow, but we did have a polling issue. And I'd like to say it feels smoother now, but honestly, it makes no difference. But you saw we had a start event, and now we actually have an end game, and nothing happens here as well. But the issue with the end game is we can actually do the same thing here. In the end game, we can actually make space start a game again, and this will always be magic in the middle of nothing happening. So we press space to start, and we see new game starting. Then when we die, we press space. We press space. Oh, I know why. The reason why is because we don't switch to the state, and that was the reason that I actually made game state here step. Because now we actually have to have checked this one out if the game is dead. Game and dead. Alive. And we should probably put a function when say game state dot game over. And then what do? Then we're going to do game over. And game over simply puts the stage to stage dead. I don't know why I called it game over. Dead is probably a terrible name. Stage, let's call it game over. Stage game over is a much clearer name. Stage game over. Call game over. Dead. Where's our main function? Dead. Stage game over. So I hope you saw how the select works. The select picks the function and then calls it, and they all have the same signature, so that works just fine. Alright, and now the game actually needs a function called game over. Let's stick that right at the end. Or where's the alive word? We can stick this at the end. So this class is getting fairly big. I like the fact that we have big files here because for Leaf, this tells me a lot. We have an actual app here. This is no longer like some random little toy. We actually have a real app running here. And this code is already large enough that we can tell that stuff is actually working. We know what's not working, what is, and it gives something working. Not quite as big as most of our coding game shows yet, but still getting pretty close there. Actually, probably about pretty close. Game over, and we're just going to do return not alive. It's a very simple one here. And you notice it's going to determine the type all on its own, hopefully. Oh yeah, not is not reserved. I'm actually eschewing old operators in favor of stuff like this, not alive. Ooh, what do they do now? We got something weird happening. Well, I'm going to do it this way then, okay? Just to not tempt fate. I screwed something up somewhere. So we hit a fairly low-level function in... Very low-level error in Leaf. Because this error is coming from the compiler. It's not even error with the source code. It's the compiler saying that has done something horribly wrong. Let's figure out where that is. Main app, I don't think it's here because that was working before. An app is stage game over. Let's get rid of this for a second and get rid of this and see if that's what it was. So one of those is causing the error. Let's figure out why. Not that one. That one's fine. Oh, I see the problem. This is not a function. What the hell happened here? So, this thing breaks the compiler. Because what we really wanted was game over and a then, because this is an if-then function. Okay, so now we can start the game. We press space to start, and we go, and we die. Then we press space to restart. Perfect. Well, not perfect, but it's it's working. So when we die, so I don't have to restart the app to get new maps and stuff. We actually can restart, and that little bear should have walked onto us, but apparently he doesn't. He just walks away, whatever. And now I can restart, but now we have to show some sort of text saying it's a game over or something. And so now we have to introduce the concept of screens. How do we actually show different screens? Because we want the game in the background, I think. I don't know. Maybe, maybe not. Alright, so that's the game over. So in the game over, we should show text saying game over. And otherwise, we're going to show text saying, hey, start the game. So let's commit what we have, though, first of all. So I have a reference point. The Sonic Seal? Well, Pac-Man's one of the games I actually wanted to do later, but I decided to start with Wormies instead. But it has a different kind of... In terms of complexity of the game, it's probably around the same complexity as a Pac-Man game to implement. And I will do Pac-Man maybe on a later show. I intend on going through a lot of the classic games. The reason why I want to do classic games is because they're capable to do on a show. Modern games are extremely hard. There's so much level of complexity and there's so much graphics involved, it's hard to go through them. But classic games are a lot easier. And also because Leaf is in its infancy, these classic games were written when you really had things like Basic Assembler and Basic C, so we don't actually need a lot to implement them. So we really have a lot of leeway, a lot of options to do them that way. And so, but Pac-Man will come. I'm going to do Wormies first, and then we're going to extract libraries from it so the next game doesn't take nearly as long to do. And Wormies app.leaf will make proper libraries and stuff and everything. You see, this one doesn't even have its own repository yet. It's just in my SDL repository. Game stages. Okay, so now we have to do screens, and these are rendering screens, and this is where it's really unfortunate I don't have traits yet. Okay, because the reason why is this select thing here can select functions, but we can't select distinct objects because we can't create something called a rendering item, right? Because we have this generic renderer, but we can't select which one we want to do in a simple select. We're going to have to fake it, and I mean, we can do it. There's a really ugly way to do it, but we're not going to do it for now. So in the actual renderer, the outer body renderer, where's that thing? Game renderer. We're going to start splitting this off into files because this is getting a bit big, 508 lines, and we have these files. So this is a top level one. Game renderer has that. Let's start splitting these files off. Let's stick this here first for reference. We're going to come back to that. And let's go down to... Let's put all this type code into utility functions. Wrap, normal, geo, float, util, lerp, max, min, max, segment point, angle, point to NDC, size. These point to NDC stuff, this is uncertain whether these actually belong, because these are more like the actual renderer. This other stuff is very clearly generic. I just call this math. And that's okay. Now in Leaf we don't have to modify a project file. We use the file system. The fact that this file is part of the directory here is enough to say it's part of the project. And there's no ordering. There's no header files. Declare anything wherever the hell you want it, and it'll figure out what order it needs to process them in. And that makes it super simple to do this type of stuff. Even within a file. Within a file you can do things out of order, and that makes splitting up and refactoring super easy because you can so easily just throw things in different files and just not worry about ordering whatsoever. Heading live, yes. Select is very similar to match, but it's it's very rudimentary right now. So our select up here, so the one on main, it has the condition matching. What it doesn't have right now is that you can't do like select app inst stage here and then do this down here. That would come next. But yes, it's going to end up sort of like match. It'll work slightly differently, but match is one of the things I really like from Rust, and Rust's pattern matching I think is a really nice way to go to solve some certain problems, and so we'll definitely see that slowly migrate into Leaf in terms of let's get matching, let's get the basic pattern matching going, and select will probably go away or be replaced with match-like syntax, and I'm unsure whether it's select or match. Both of the names aren't perfect, but if you're doing pattern matching, maybe select is kind of the same. But yeah, so anyway, yes, it's going to be like match, but it's very rudimentary right now. Alright, so we have this math leaf, which we've moved a bunch of stuff out. Now we have game renderer, and what we want to do here is we want to separate out the game UI renderer. Let's stick that in a different file. Game UI renderer. Now this is actually a bad name for it, but I'm not going to mess with the name at the same time as I do refactoring. We stick that out here, and now the game renderer. Let's stick the field renderer in a different file, and the field renderer is going to take the segment point angle with it, and we'll put this in a different file as well. Game field renderer. Now, if you see the pattern here, what we have is a bunch of renderers, and what I cannot do in Leaf yet, is I cannot say that this implements some sort of renderer interface. I cannot implement a trait for it. It's like the big to-do. After doing this show, I realized this is like something fundamentally missing, and it's very hard to program without it. I mean, it's not very hard, it's a fundamental lacking concept in Leaf, and so that's making it really high on my list of things that are fundamentally lacking, and that'll come next. It's unfortunately extremely hard to implement, so we're going to be months away before we have that. So we're going to keep implementing this game the old-fashioned way, without object-oriented programming. Okay, so we have game renderer, and point to NDC. This is for the game coordinates. I'm going to leave them here. Alright, so we have this UI renderer, and to show you that nothing's changed, I should just be able to run it again, because nothing's actually changed. And I didn't change the command line or anything, everything just works. So refactoring into files is super simple, and I really like that approach. And again, the ordering doesn't matter. Alright, so now I need to do it, and this is why I say game UI renderer is not so good, because we're going to have a menu. Game menu renderer. And this is where select differs than match, is I can't really execute a function in here. Well, I can, but it's actually, you know what, maybe I can, because it has to return a value, but I'm pretty sure I actually support not. Yeah, no, let's not tempt fate first of all. We could try to do it later. So we're going to do this app inst.stage equals stage menu. Then do this. Else app inst.stage equals. Actually, I don't even know if this works, to be honest. Stage play, then do this. Right? I don't even know if an else if works, but in theory it might. Else we do whatever the hell comes down here. So we have a menu renderer, so we're going to stick the menu renderer in here. We're going to do menu.render state UI region. And again, this would be a lot easier to do if these all had an interface, because then you could very easily select all of them and it would unify to that interface or to that trait in Rust terms and call it. But since we can't make a class that shares the interface, it's very hard. But we could actually pull the render function out, and that's another option. And let's see what that happens. But because we have different setup for each of them, it's also doesn't work. So I'm just going to stick with the if then for now and forget about select. Let's just forget about select for now, knowing you can come back to it. And that's a big to-do. I don't have to put a to-do there because that's more like a structural thing. And so the game UI renderer, where's our render function? I'm going to have to take something that looks like this. And we had a game menu. Actually, I just quickly save this as game menu renderer. And actually, I'm going to do something stupid. I'm going to take all of this stuff out because we actually want to redo this stuff. We want to share everything we can do. We want to make this higher level so that these states don't know much about GL anymore. Render. All it should have is a render thing. A good game menu renderer and game renderer as a game menu renderer. And menu renderer.render, so that should be enough. We're not going to see anything still though. No conditional nesting. Oh yeah, see, look, I even have that error. No conditional nesting. So this bit here, this else, you can't do conditional nesting right now. And, well, that's kind of silly. But we can do it this way instead. Yeah, these are the joys of working on a language. Conditional nesting. Probably too many exclamations. It's not more important than anything else. App inst, where is that? Oh, we have that. We actually passing down the game, and now I'm going to make this function take the app inst instead. And this is a shared game app, I called it. Game app. Shared game app. This is an app. And these other ones don't need to know about it, so I'm just going to say app.gamestate. This may or may not be good. They should probably take the actual app, but we can slowly change it bit at a time. App inst. Oh yeah, that's where we have actual. This is app inst. App inst. UI region is. Oh, I passed the wrong one. The main menu is going to take the whole screen. And again, we still see nothing here. But you notice the menu at the top's gone, because the game hasn't started yet. Once we press space, the stuff in the top comes up, and that's what we wanted to do. Now we just have to start redoing stuff. I'm going to refactor that menu at the top first, and alright, we'll figure out what the top thing is there first. Because most of the stuff from the UI renderer we want to reuse. Game UI renderer. And this is where something like inheritance would be really, really, really helpful, because you could actually reuse most of this stuff. And we're going to have to do it a different way now. We're going to have to create a way, we're going to have to create something called a, well, let's call it a generic UI renderer. And we're going to split this into what's generic and what's not. Alright, how do I do that? How do I do this? Trying to think of how I do this now. Alright, so we're gonna split this up. This is like the classic sort of C way to split this up rather than C++ or high-level script. I'm gonna have to make this a common class. And so bear with me as I save a copy of this again. Save as generic UI renderer. And it's not actually a generic renderer, and so the name may not be right. Generic UI renderer. And it has a program. And it doesn't have these textures. It knows nothing about the textures. Everything else is going to keep, though. And it has a font, maybe. Maybe it has a font. Let's just double load the font for now. That's not a terrible thing if we double load the font and we double TTF init. That might be a problem, so we'll find out right away. So this is the bit that we get rid of. And let's match this with the game UI renderer. Game UI renderer. It doesn't have a program. It has these two textures, and it doesn't have all this other stuff. It has last score, but not that. And what it's going to have is it's going to have a generic, and it's going to have a generic UI renderer. It's going to have one of these things. And it's going to take the generic font, generic.fonts, and this is where we probably shouldn't even call the GL function directly. We should actually wrap that as well. And so now we'll get rid of all this stuff here. In its render functions, we're going to, this makes sense. Now this other stuff here, alright, this is where we're going to have to call generic dot, let's say start, generic dot end. We're going to call a start and end, so in theory it can do multiple things. But let's start patching up there. So we create the font here. We attach that. We got rid of the text stuff. Now on the render function we don't have the state. We don't even have the render function anymore. We have the start. And start should not need the state anymore. Start should take a region though. Start probably wants a region. And end won't need a region. And our end is going to do nothing. Define end. And here we don't call these draws anymore. This is basically very simple. We're just going to start and end. And this draw text now is what's going to do it. Draw text takes a region, and so maybe start doesn't need a region. I don't know. I don't know whether draw text should take a region or start. Let's just leave it in text for now. And now this one is actually going to draw the stuff, and so in our start render over here, when you generic.drawText, and it's no longer a private function. Again, we don't support private and public just yet. We're just using an underscore technique. And this doesn't have draw text. So what I've done is I split this into two parts. This is the specific part for our game renderer, and the other part is the generic one that we're going to reuse. And this should simplify the other menus we want to do. And surprisingly, I didn't screw that up. Wow, I actually didn't screw up the refactoring. That's like amazing. Such a rarity. I really want that apple. Come on, apple. I'm going to stop as soon as I get that apple. Yay! Boom. Okay. And so the menu disappears. And I'm going to take, I added all sorts of stuff here, so I'm going to add a whole bunch more. Git add Wormies. I'll just add git add Wormies. I'm going to remove this cache grind file. Oh, actually, for curiosity, to show you what I meant earlier in the show, with the startup time we're getting is not coming from my compiler. It's, well, it is, I mean, but it's not coming from my modules. It's coming from LLVM. So if we look at the elf object here, LLVM has 80% of all the execution time, and that's in the startup there. That's completely the startup time until we get the main window. And libleaflang. This is the entirety of what I do, is a tiny amount. Now obviously most of this libc is still in here because of allocation. But if I get rid of this, if we look at it inclusive or self, it's this pass manager, and this pass manager consumes a lot of time, and it's all this, it's a lot of LLVM stuff, pass manager, and I had to figure out why it's taking so much time. And this is actually, this is not my construction of the tree, it's like the actual execution, and it's like right here, this function called find analysis pass. I'm curious as to why it's called 3 million times. I don't know what it's doing, so I'm obviously doing something weird here, and I got to figure it out whether this is my fault or LVM's fault, but clearly something's wrong here, and this is why the startup is taking so long, is because of all these things called millions and millions of times in LLVM. Like again, this dense map lookup, which is part of that. Whatever find analysis pass is doing, it's being called too often, and I think this is the complete responsibility of why this is taking so long, and I just don't know what's doing that. And I'll have to ask the guys in LLVM what that is. Why is it calling this so much? Because, again, this is actually part of the same thing. Why is it calling add integer 6 million times? I can absolute guarantee I do not emit 6 million add bytecodes. Alright, but that's a sidetrack. I'm going to remove that for now. I can regenerate those as much as I want. Git status, git commit, splitting off screens. Push this again just so I don't screw it up. So now we have the first game renderer, and we have a UI renderer as well. So if we open the UI renderer, game menu renderer, it does nothing right now. But we can basically copy the UI renderer and work from there. Alright, so now we have the same thing, but now I want to have text start and text quit. I want to just have two options in the screen. We're going to start working with options here. And those shouldn't need the same thing, but let's just deal with that. They don't have a score here. Text starts is going to be just the text start, and this is going to be quit. Text quit. And render, we're going to start it. And then we're going to draw these two functions. We're going to do get op text start. Again, this get op shouldn't be required, but it's there. Quit. And where do we actually want to stick these things? In an actual layout system, and I eventually want to do this, I want to migrate the Fuse one into Leaf. I would have like a stack panel, but for two menu options, I'm not going to be after creating a stack panel, so we're just going to sort of stick these somewhere in the middle. This goes into lossy region.region size.x divided by 2, right in the middle. And it's going to be centered, completely centered on the text. Now the issue is, where do I put this? Let's just put these at, let's put them near the center of the screen, so lossy again. Lossy again because we're technically losing data, and Leaf doesn't allow that by default. Size.y divided by 2. And for the next one, we're going to do the same thing, text quit. And we'll just say plus 40 here, plus 40. So now we have a game menu renderer, so we should see a start and quit option now. Except I made an error, 17. Where did I make the error? I forgot to close off lossy. Text quite. Text quite. Not what we want. Not quite what we want. So there, we have a menu. Doesn't look like a lot like a menu. It's kind of small, but we can deal with that. We'd like to change the color of that. And so let's actually put a simple navigation with the arrow keys, how we navigate up and down. And so we're going to have something like, and this could actually be an array of options, but let's just do it var active is an integer. And how do we actually do this now? We're going to do... Now, mapping keys around is really a pain to do. We're just going to do some deep access into these functions right now, which is really bad. Really, really bad in application design, but without a full layout and UI system, this is extremely hard to handle. Even with a layout system, handling keystrokes, passing them deep into the tree is a real problem. It's just not something you can easily do. Key event key sim equals edA-qa. Well, yeah, let's just make space do that. Okay. Space is going to choose the option, and what we're going to do is we're going to treat that renderer as the actual object. So we're going to treat this as the high-level business logic object as well, not just the renderer, even though it is kind of a renderer. But at this point, it's not actually a renderer because it doesn't have a renderer in it, so it's like really getting weird here. It's like a component, and the component has the renderer and the stuff in it. And so we're going to have this, going to have an up function and a down function and a select function. Oh, can't call it select. Activate is another correct word. So active equals mod active plus 1, 2. And actually, this is going to be probably -1 because we're going upwards logically. And this will be us plus 1. And activate, we'll figure out what that is. So, like I say, this is really tricky now in how we do this, because what activate actually does, we're going to have to pass this out. So let's just worry about up and down for now and just ignore activate. And this has to go deep into it. It needs the render, and the renderer is also kind of private right now, though. So I'm just going to stick this out here again. Shutter. I'm going to hide my face again in shame by making these globals. And you can see the type of stuff, this huge amount of work that has to be done in basic layout. And when you're doing a game, why you don't do a game from scratch, why you pick up a library, why you pick up like Unity, why you pick up Unreal Engine, why you... Like, even SDL only gets you so far. There's layers on top of SDL that do these menuing stuff. And you should definitely start that way, because if your point is to make a game, you don't want to be dealing with all this stuff. You actually want to be dealing with the game. You want to have a layout engine and stuff. And I will eventually make a layout engine, but we're going to see what's actually involved here. So what I mean now is a deep inspection is now we're going to do in the renderer, which is totally non-intuitive, in the menu, render.menu. So the renderer and the state are not separate. This should be a logical state. And menu renderer, wherever it was, main.up. Down. And activate. And activate. Okay. So we have the menu renderer now, but what we're missing is I don't have a way to change this color. Right? So I don't have a way to change the color. So let's do something really rough for now. I'm going to put this on a different line. And I'm going to put minus and say active equals 0. Let's do 50 or 0. Just so we can see they're selected before we can change the color equals 0, 50 or 0. Now if this works, a big hopeful thing, it compiles. Uh-oh. Oh no. That's bad. What'd we do wrong? Oh no. What did I add? Well, it can't be the keystroke stuff. Let's just do nothing here. What did I do wrong? That's really wacky. Well, that's fun. Well, let's debug. Now, debugging is really weird too when you debug a virtual machine, but it should go directly into our stack with like somewhat suitable names. Alright, so you can see we go into the MCI JIT, which is the LLVM thing, and into main, and into an init module. And this init module, yeah, this is probably because we made Game Renderer global. So nothing to do with this. If we look at Game Renderer itself, it might be using some globals. It might be doing something. I don't know what it is, but I'm highly assuming it's probably because we made Game Renderer global. Caused init seg fault. Oh yeah, and this I actually know why. I know why it did this. Because you can't actually initialize a game renderer until the type itself has been constructed. But these are both in the global namespace, so globals are really bad in this sense. But in any case, I shouldn't be creating a seg fault. Something obviously should be happening. But now this creates us a little bit of a trouble that we need to have. We either need to pass it down. Yeah, let's just pass it down for now. Our renderer to game renderer. And the renderer is a service, so we don't have to worry about shared things. And so in all these functions, we're going to pass app-inst renderer. We're going to pass a renderer, which is a game renderer. And this wouldn't be a problem if we actually had this properly structured, that the app instant actually had this logical state in it. But so long as we have these separated, we're going to have to deal with it. Now these are spawning multiple lines, so I'm just going to put them on different lines here. And that's just because the font size is so big for the stream, I think. Yeah, no, it's actually spawning lines anyways. Okay, that should probably, hopefully fix it. Renderer, and that's in line 86 now. Renderer. Maybe render would have been a better name. Alright, well, I forgot to change the index. You can definitely see they switch around, but we don't actually see the highlighted one, and that's because the menu render I put active equals 0 on both. Alright, so we can actually select it. Now, this is a problem I've had with actual real-world video games. When you have poor feedback and you only have 2 items, it's completely unclear which one's actually selected. But we're going to change the color anyways. But even with color it's going to be unclear which one's selected unless we increase the size of this thing as well. But let's figure out how to change the color first. But we can see the keys are working. That's the main thing. Keys are working now. Perfect. Keys are working. Let's do that. We have a basic horrible menu, but it works. And how do I draw the text? This is the generic UI renderer. When we render the text, you know what, I think I've hard-coded that text color in the actual lib, the GL, the STL text. From text, right here. I actually hard-coded the color in. We're going to make it white now. And I'll show you why we're going to make it white. FF. And this was actually something I have fixed. This is actually supposed to be an STL color struct. And in theory, I fixed that. This was all about API conventions, so this should actually be now. This actually looks more complicated now, of course, but it's more correct. Our text is white. Now, why did I make it white? Because I'm going to actually multiply by the color in the actual fragment shader. So let's open up the fragment shader, and that is, where's our fragment shader? Not in this directory. In Wormies, we have a text block fragment shader, and it has a texture, and it should have a color as well. Uniform, and it's allowed to be transparent, so it's going to be a Vec 4, and we're going to call it tint. That's the correct thing, and we're just going to say times tint. But now we have to set that value, because if we don't set it now, we're going to see nothing. Right? It's because we're tinting the opacity. Now it's completely clear. So what do we do is we're going to have to actually set that color, and we're going to do that in the generic UI renderer. Right here, when it sets the univerb position, we're going to set a second uniform. Set uniform tint position, which is a position of it, and we're still doing uniforms wrong. We shouldn't be looking them up. We should actually just give me a fixed size, and I can probably do that afterwards. Tint. And right, so the standard GL way of doing this is not to get the uniform location, but rather just to have this fixed, and then in the fragment shader make it fixed as well. And I'm not entirely clear why people do that, but everybody I've ever talked to who's done graphics does it that way. I've never gotten so deep in these things that it never made a difference for me. But for our debugging, it makes an issue, because if I ever remove tint from the shader, this part breaks and we can't do it. It gets annoying. So using fixed locations actually does make sense. Tint position. And now let's just give these things a color. I foolishly removed the color we had before. What color was that roughly? A0FA. So it's somewhat bluish green. This is now in this is going to be curious because these are floats, not integers. And it should be that, don't need that, and it was 0.9 of green or 0.8 of green and 1 of blue. Let's see if this actually works. An open tuple. I screwed that up. Alright. So now they're a brighter blue, which isn't quite what we wanted, but it's okay. And what do we want to do now? We wanted to make it like, we don't want to put the color here at all. The draw text should actually take a color. And this should be a GL float 4 if I have such a thing. I don't know. Color 0, color 1, color 2, color 3. Do I have a float 0? We had that math library. Do we have a float 3? Do we have a float 4? Probably not. Let's just make a float 4. What we also can't do in Leaf yet, which I'd also like, is actually have field aliasing. It's used in GL a lot. It's not really very high up on the list, so I'm not even going to make a to-do for it. But now draw text actually has to draw the text with a color, so game UI renderer has to pass a color in as well. And this was 0. I don't know what it was, 0.8, and this is 0.95, 1. And back in the menu renderer, we're going to give these things colors as well, and that's where we're actually going to change the color. Get rid of the active. Active equals 0, then we're going to return that color or the other color. And what color do we want if it's selected? Obviously we should not duplicate this bit, but let's just go with it for now. Should it just be darker, or should it be brighter, or should it be red or purple? Let's just make it purple. So the one that's selected will be purple. And this is supposed to be active equals 1. And get rid of this. Alright, so now we actually have a proper menu. Again, we're working from the very basics here. If you've never done this type of stuff before, if you've worked with like a layout engine, HTML, CSS, you'll see the amount of effort that's taking involved here. And this is because we don't have a layout engine. We don't have anything like that. And this is what I meant though. When you have a 2-item menu, it's very unclear which one's actually selected. And so that just, yeah, there's many ways to fix this. I don't care about it now. We know purple's selected. And if we press space, it should activate it. But we don't have any. That's the next step. The next step is, well, how do we, what should activate do? This class doesn't know about the game state. So what should it do? Oh, people yelling outside again. Okay. The easiest option here for now is to give it the app state. And this is the game app. And our game app is a class, and this should really be a service. But we call it shared for now. Let's just say shared. It's a shared game app. And so we're going to do a hard coding thing here. Active equals 0. Then app inst.start game. And we return and active equals 1. Now we have another real issue. What should we be doing here? App inst.quit. But quit isn't handled by the app inst. So how do we do that? We're going to do this. Define quit. And we're going to take over what was in main. We have a run thing here. Run equals true. And we're going to do app inst.run. We're just going to stick it over on there. And app inst.run, app inst.quit. You can just call it now. When the user presses quit, they quit. Quit, and over an app, quit, run equals false, and we make a public variable as well called run, which is a boolean, which equals true. Now if I didn't make any mistakes, which I did, oh, I forgot to pass it in, main leaf 91, this needs to have the app instance as well. A lot of work for simple gains, I know, sorry. So quits the game. Wonderful. And starts the game. Great, we have our very basic menu. And we're going to save it at that point, and we almost hit the bear. We have to do the endgame menu now, because when you die, there's no menu. So what's the easiest thing to do in dying is, for now, it's actually just say, well, let's make another menu. That's very simple. Game render, let's do var game over menu. Game over. I'm not going to call it a double game over render. That's kind of a bit silly, although it would be the correct thing to do. App inst.stage equals stage game over, and this just takes the whole screen again. Render app inst.game state region game over render, and now we need a game over renderer. A menu render, we're going to start from here. Game over renderer. And we're not going to give it any options. We're going to just do, well, let's actually do restart. Let's go I have no idea. It should just be return to main. Return to main function. There's nothing else you can do. We'll make it look like a menu, but there's no buttons here. You don't have any options. And return. We're still going to say active equals 0. We're just going to get rid of the second one. And this is, I'm leaving it like this to indicate that we should probably have a common menu selection. Like I said, we have a common menu component that takes these things and says what should happen with it. And we can even leave up in here. And this is actually up mod 1, which is like all utterly stupid. And activate 0 is going to be return to main. And let's actually make this thing return to menu. That's a really simple, really silly thing to call it. Return to main, return to menu then. And we have to put it in the leaf here, var return to menu. And now we say stage equals stage menu. So we go back to the menu. So if we did this all right, text start, no, we didn't do it all right. Text start is text return. But you can see the rudimentary bits of how we want to start creating a UI system. Alright, so now we can start, we play, and we die, and it's rendering the wrong one. Alright, so we actually went to the wrong place somehow. Game over renderer, return to menu. In the game renderer, what did it do? Stage game over. Ah yeah, it's rendered the wrong one, game over renderer. And in the main leaf, we're actually going to have to pass these functions over as well, which further indicates that there's a reuse here. There's something generic about these. These things are the same component. And where we handle the keys, the component should probably handle the key, not us. And that's where the duplication comes from. So we're going to start, and we're going to create a game, and we're going to die right away just so we can see it. And now we have the option, we only have one, and I can quit. And you know why? Because I said renderer.menu. And this is where it really sucks. This is where like this direct deep linking is actually wrong. This is like really like stupid. Start. Alright, die. Now, well, you can activate and deactivate it, strangely enough. But activation doesn't make a difference. Activate app inst. Game over activates. Where's the game render? It has game over, game over, game over. Game over renderer activate equals 0. Strangely, I don't think my mod 1 is working correctly. Because mod 1 should always return value 0. To do mod 1 should always be 0, but it's not. So we're just going to do active equals 0. We're just going to do nothing here. And active will start as 0. And then we should return to menu. And in the main, in the app, return to menu says stage equals stage menu. That's supposed to work. Start, die, and we're not returning to the menu. Well, let's see where it's actually calling it. Let's go to the game over renderer and let's see what happens right here. Standard.print line. Activate, comma active. What do we have here? Are we being called? Alright, so we initialize the TTF too often. That's fine. I hope it works. We end here. Oh! And we do definitely activate it. Return to menu and activate equals 0. So in the app, what does happen? Println, return to menu. Oh yeah, it has to be a tuple. I don't have variable arguments yet for this. Only it is a variable argument function, but it has to be passed as a tuple. Alright, so we return to menu. What do we have? Huh. It is returning to the menu, it's just not updating any of the graphics. Curious. So it's definitely gotten there in stage menu, so let's actually report what stage it has now. Let's go to the main. App inst is a shared game app. Shared game app. What have I done? Why is this not working? Well, let's just print out which one we have. What game managed to generate? Print line. Stage is app-inst.stage. So stage 0 is the menu. Start with stage 1 is the game. Stage 2 is the end. And it doesn't go back to stage 1. I think I'm taking a copy of something somewhere, and that's bad. App install return to menu. It's weird, 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 weird. Now, what have I done wrong? Let's close some of these files that are getting in my way. We don't need this fragment. Do need that. We don't need that. This is game over renderer. Game over render dot render shared game app. So something's not getting the update, and it has to do with this game over render. Something is somehow not getting the value. But it can only be in the game over renderer, because that's the only thing that's different, because the menu and the game both get it. Oh, that. If by any means anybody has seen the error I made, please let me know. App inst is here. Space over app inst.stage. Start. Die. And we momentarily see it, stage 0. So it actually recovered it, and then it keeps going back to stage 2. And that's a shared game app. Well, what does it do? Let's take that out there and put it right here. After the key goes down, we're going to see what state it's in. Stage 1, stage 2. And it says in stage 0 now. Oh shit, you know what it is? I know exactly what it is. This is the logic of the game itself, the app. In the step function, if it's a game over, then we do game over. But this should actually be stage equals stage play and game over. Because otherwise, once it's game over, once we're dead, it never goes back. So that would actually be doing that there. Logical, no? So we start, then we die, and now we can go back to the menu. So now we actually have proper menus. Now we can play the game multiple times, which is perfect. Now that was a bit unfair the way I started, but that's okay. So now we actually have that bit, and I'm happy with that. Happy, happy, happy. We have rudimentary menus, and for me this represents like a massive gain in what the compiler can do. We've actually come a long way, so we have a game with actual menus in it. And those menus, so we have a multi-stage game that when you die, there's only one menu option, but you can return to menu. Maybe I should add a quit here just to show the purpose that you have another one. And then you have a start and quit actually works. So let's actually add a quit function as well, just to show that it's a menu. And just for the fun of it, text quit. Quit. I have no idea why you'd want to do this, but I just want to show that it's an actual menu. Text quit, draw text, text quit. And we're going to have to simplify this further to create a proper engine out of this. And we're just going to say plus 50 here. Plus 40 was the other one. And active equals 1. I'm still going to leave that 2 to you because I know what it is. Up 2, active equals 0. And otherwise, we're going to say active equals 1. Again, you'd actually want to have independent actual buttons in a list that can handle this directly. But again, when you don't have a full library, you're dealing with this a lot. And you'll see a lot of this in simple games. In simple games, if you don't have a lot of layout, you don't want to bundle a big layout library for simple stuff, but also there's not a lot of good layout engines out there if you're not using like a full framework. And we'll put quit here. So now we have an actual menu. And notice it takes longer and longer to compile, so we start. And now we can actually return to the menu. We start. And that's the space bar I'm pressing to start. I should make it support enter as well. And you can quit. That's perfect. I think we have covered all the basics I wanted to do today. Alright, so let me tell you a little bit what I want to do next time. Commit adding menu selections. So what we covered today was actually quite a bit. Let's go to the game and let's see what we did. And I'll talk about again what we covered. And if you just happen to join us late in the show, the significance of what we covered is because, again, we have a language without a standard library, so there's very little done for us. So what we actually did first is we did this up here. We did proper alignment. So we have text alignment that actually aligns the top left and top right, and that's dynamic based on the number of points you have. So if I get to 10 points, let me get to 10 points, you can see that it stays right aligned up there. And I gotta avoid that bear-like creature that actually looks like a cat. And I didn't get him right again. So when I get to 10 points, you'll see that it actually goes over and... Damn it. I'm not very good at my game. So you can see that it's right aligned up there. It's 10. And the font is proportionally font. I don't think they're always the same size, the letters. You can see them move depending on what the second letter is. Oops, and I pressed the wrong one. And so now we have a menu. You can return to menu. And this was the second thing we did. We created these menu systems. And the menu itself is extremely rudimentary. We have a simple up and down, and we change the color only. Purple is the one we want to select. And we pass keystrokes through. So we created the actual app structure. This is the basic structure. And because we're limited to Leaf now, we don't have interfaces, and that's the key thing missing is interfaces. We have to do this in a fairly rugged way. Like, it's not very clean. And there's lots of stuff missing, and we're also missing a UI system, but we'll slowly add all of this as time goes on. And we should probably make the text bigger here. But again, the text here is actually point-based, so it's not relative to the screen size. It's point-based, so it's always the same size. And that's with the title text as well. And that helps for such menus like that. And we don't have a stack panel, but that would be the next step. And we still have some issues with the way the game starts and stuff. But at least we made it far. We got actual menus. You can actually restart the game. And the game can actually end. And so now, what we'll do next time, what I want to do next time is I want to go back to the graphics just a little bit before I start doing the artificial intelligence person. Artificial intelligence, I think, or like the component player, maybe I'll start that Sunday if I get a chance. I'm reluctant to go too deep into it now because there's some stuff we have to clean up in Leaf first. And whereas graphics, I can work on graphics right now without having to go too deeply in Leaf. So what I wanted to do is when you start a game, except for the stupid blinking right now, which it usually doesn't blink. Let me show you again. That's actually an error that is blinking. When we start a game, okay, the game's paused until you press a key. This is perhaps good right now, but you have to hunt for the screen for where you are. And that's really not so good. What we want to do next is introduce sort of a temporary stage in between where the worm doesn't start moving, but he scales in, so he's really big and he shows you where it is. If you remember classic Pac-Man game, Centipede, and a lot of those games is that when you died and you came back to life, it showed a little graphic showing where your character was again, so you knew where you were. And we have to do the same thing here. So that when you start the game, we're not going to wait, we're not going to start in a pause mode. We're actually just going to start immediately, but we're going to give the user like 2 seconds or so where they can actually see where the character is and adjust to it and then start moving. And then I'm trying to think of what, and once we do that, those are the key graphs. That's actually probably going to take a full episode to get working correctly. And then what can we do after that? After that, we can start adding, maybe we should add the AI guy. Again, I'm kind of reluctant to add the AI guy, but it actually would make the show interesting if we added an actual AI player. And we can add another menu item, say toggle on players on and off, number of players. And for now, we do that. Or if somebody wants to do gamepad first, I also want to see get gamepad support, but that's a fairly straightforward thing, I think, with SDL. Not a lot to see in the code other than the SDL stuff, so we have a lot to do. So maybe we should do the AI player first, just because it's fun, and we did it before in Tron and Coding Game. And then we can actually explore a bit about how IA works. But I think I've covered it for a day as I lose my voice here. What I'm going to do is I'm going to play the game and do a progress report as usual onto YouTube, just because it's fun to see these things on YouTube. And we have an actual menu now, but the progress otherwise doesn't look so much. And that's why I also want to work on graphics a bit, because it's nice to show actual progress and probably change the stream title graphic to this. But I thank you very much for watching. I hope you had fun, and be sure to tweet and retweet my streams and follow me on Twitch and Twitter just to make sure that everybody sees it, and it keeps the show interesting as we have more people and asking questions. And again, always ask questions. Thank you very much for watching, and have a good evening.